this is the assignment problem which we can solve by using Hungarian method. So the problem is that a project work consists of three major jobs for which the three contractors have submitted tenders. The tender amounts quoted in lakhs of rupees are given in the matrix below. So this is the assignment problem which we want to solve. Find the assignment which minimizes the total cost of problem, assuming that each contractor has to be assigned one job. Okay. So these are the three jobs and these are the three contractors. As a first step, we want to find the minimum value in each row and subtract it from the other elements in that row. So in the first row, 17 is the minimum value, so I subtract 17 from the other two elements. So 17 minus 17 is 0, 25 minus 17, 8, 31 minus 17 is 14. In the second row, the value is 10. The smallest value is 10. So 10 minus 10, 0, 25 minus 10, 15, and 16 minus 10, 6. In the third row, 11 is the minimum. So 12 minus 11, 1. 14 minus 11, 3. And 11 minus 11, 0. So as a next step, we can find the minimum value in each column and subtract it from the other column elements. So in the first row, 0 is the minimum value, so there is no change in that column. So 0, 0, 1. In the second column, 3 is the minimum value. So I subtract 3 from these elements. So there's 5, 12 and 0. Then in the third column, also 0 is the minimum value, so there is no change in that column. 14, 6, 0. Now we can assign each zeros by the type 1 of assignment problems. So in the first row there is 1. In the first row there is 1 0, so I assign this 0 and cancel the other zeros in that column. In the second row there is no more zeros, and in the third row there is 2 zeros. So I cannot do anything. Then in the first column there is no more zeros. In the second column there is 1 0, so I assign the 0 and cancel the other zeros in that row. So now there is no more zeros to cancel or assign. Here each row and each column have not one assigned 0. That is, the second row and the third column have no assigned 0. So in this situation we can use the Hungarian method. As a first step of Hungarian method, we want to pick the row that has no assignment. That is, in the second row there is no assigned 0. Okay, so I pick this row. Then pick the column that has the cancel 0. That is, in this row, in this picked row, here have the 0. So I pick this column. That is the first column. Okay. Then next step is to pick the row of assigned 0. In this column, there is one assigned 0. So I pick the row of this assigned 0. Okay. First, there have 3 steps here. First, we have to pick the row which have no assignment. Then pick the column which have 0 in that row. Then pick the row which have the assigned 0 in that column. Okay. Then next step is to draw the lines in the unpicked rows and picked columns. Unpicked rows and picked columns. Unpicked rows and picked columns. Okay. So here the third row is the unticked row. So I draw a line here. And ticked columns. So here the first column is the ticked column. So I also draw a line here. Okay. Then next step is to find the smallest element in the from the not lined elements. That is smallest element which is not covered by the lines. Here only these 4 elements are not covered by the lines, and the smallest element here is the 5. Then we want to subtract this number from unlined elements and add this number in intersected elements. Okay, so here that the smallest element is this 5. So I want to subtract it from the unlined elements, from these 4 elements, and add in the intersected element. That is, here the intersected element is this one. These 2 lines are intersected here. So this one, I want to add this number here. These 4 elements remain constant. These zeros remains constant. Okay, so I write it in here. This 0 have no change, so I write 0 here. Then 5. Minus 5 from the unlined elements. That is 5 minus 5 is 0. Then 14 minus 5 is 9. And here the 0 have no change. Then 12 minus 5 is 7. 6 minus 5 is 1. Then here we want to add the intersected element. So 5 plus 1 is equal to 6. Then these zeros have no change. So this is the new matrix we got here. Then the next step is to assign these zeros as we do previously. In the first row there is 2 zeros. In the second row there is 1 zero. So I assign the 0 and cancel the zeros in that column. In the third row also have 2 zeros. In the first column there is no more zeros. In the second column 2 zeros. Third column there is 1 zero. So I assign the 0 and cancel the zeros in the row. Then I repeat this step once more. In the first row there is 1 more zero. So I assign this 0 and cancel. There is no more zeros to cancel. So now we have each row and each column have 1 assigned 0. So now we can stop the steps here. Okay, now the final answer is the original value. That is, this is the question matrix. So the original value in these assigned zeros position. We want to add that values. So the first assigned 0 is in first row second column. Here first row second column it is 25. So 25 plus. Okay. Then second row first column. Second row first column it is 10. So 10 plus. Then third row last column. That is third row last column it is 11. So here the final answer is 46. Thank you.